go here. So, hi everyone. Fortunately, this will be a relatively quick talk because it's basically intro to website performance optimization. Specifically, we're going to look at the YSlow plugin and how to get an A on your website with it. Just going to look at stuff and try to make it so easy that you have no excuse not to do these things. So my name's Nick, and I make websites, a lot of websites, and Rails is nice and quick and easy to make websites in, but it's not necessarily the snappiest framework out there in a lot of respects. We get a lot of stuff for free though, so making it feel as fast as, we can get some instantaneous page loads in a lot of cases just by taking care of some of the basics. So if I were to come up with a ridiculous metaphor for what I'm about to talk about, it'd probably go along the lines of, say you just bought a new car and you're driving up the lot and it's moving really slowly and you can kind of smell smoke, you think, and people are giving you funny looks. So what do you do at that point? You can either return the car, I guess, or rebuild the engine, or take off the handbrake. So, yeah. The point being, we're looking for some of the low-hanging fruit here, the stuff that you just pretty much shouldn't deploy your site without because you're crippling yourself in the meantime. So there's this little company you might have heard of, Yahoo, and they might be around for a little while longer. If they're lucky. But fortunately, they've been able to pay a lot of engineers who make their websites to think about a lot of this stuff for us. And they published a really helpful best practices for website performance. That's their list of 34 best practices for exceptional performance. And we're not going to look at all of those today. Mostly because the YSlow plugin tests 13 of them. And a lot of these get, pretty precise. We've got some things on there like minimize DOM access and all sorts of crazy stuff. So yeah, let's talk about YSlow then. It's a nice plugin for the Firebug plugin on Firefox. And it looks at these specific 13 rules, and I'm going to walk through each of those real quick here and just do a quick look at what you can do to take advantage of each of these in Rails and why you want to, kind of starting with the easy and obvious stuff. A few of these, there's one here even that doesn't really apply to Rails at all, and then working our way through to some of the cooler stuff. And actually the reason I even started thinking about any of this is because I wanted to use Amazon's CloudFront service as a content distribution network for one of my sites. So, without any further ado, we're going to jump right into minimize HTTP requests. And really this is the catch-all rule for all of their other rules. HTTP requests are expensive. We're talking about not just the actual download of the file, but you're talking about the network latency involved in sending the initial request. You're talking about any sort of system and server latency involved in processing your request. And then you get to the obvious part, which is the download of the response and any network latency that happens during that. So there's a lot of pieces that go into just a single HTTP request. And add on to that, most pages, this is a very small example that I've got here on the screen, and that's 10 requests or so. And a lot of sites you look on any you look at the HTTP requests and there's 30, 40 of them going on. So really all the rest of these rules go into turning 2 or 3 requests into one, like packaging your assets or reducing the size of the downloads or reducing the actual latency of making the request. So just getting into that frame set of HTTP requests are expensive and we want to do everything we can to avoid them or make them more efficient. So pretty easy one that we can jump right into is to make JavaScript and CSS external. Obviously, we're not making any assumptions here about skill level going on, because Rails makes this pretty easy. And just good development in general makes this easy. You want to extract your code as much as possible because it's just more maintainable that way. And when it comes to websites, obviously you've got the added advantage of browser caching, which is a huge win. Anytime that you can cache a file, and so that browser does not have to ask for it again, you've eliminated entire requests right there and never have to deal with again. So just stick that code into other files. Sometimes it's tempting to drop big blocks of code inline, but you will regret it. So that's an easy starter. And moving on from there is to minify that JavaScript and CSS. I've read that it can give you as much as a 20% size reduction, and it's nothing to sneeze at. So I mean, we've got a sample minimized. If you're not familiar with the concept of minification, it just takes all the unnecessary white space, anything that's not strictly necessary to parse that file and make it understandable to a browser, and rips it out. So if you're using any sort of JavaScript or CSS framework, the work's probably already been done for you. Most will distribute a minified version with that. And so just make an effort to link to that when you do your includes. Again, this is basic stuff. As advanced as it gets would be to download some software to do compression for you, like in a rake task when you do your deploys. The UE compressor is a jar file that compresses JavaScript and CSS files, and it's pretty easy to just grab all your JavaScripts or CSSs and run them against that whenever you do a deploy, or manually, locally, and then you commit it to version control, however you like to do that kind of thing. Moving right along, stick your style sheets at the top, scripts at the bottom. And that seems like a pretty easy one to do, although I bet if you check some of the sites you have, you're not actually doing that. Half the sites I maintain don't even do that yet, but I'm getting more into that habit, mainly because when you need to include, call a JavaScript function in the body of your page, what do you do if it depends on some library? You need to have that library included first. So this is how I've been structuring a lot of my layout files. This will be like a sample application.html. And you can see in the head we've got our stylus sheet link tag. In the bottom we've got the JavaScript include tag. And then next to each of those I've got a yield block for the head and the foot. And if I ever need to include more CSS files, I'll just use content for and pass them into those blocks. And it's a pretty fundamental method that Rails gives you. But you just send in a block and it'll show up where it needs to show up. And that includes if I'm, creating a list of objects that all need to have some sort of JavaScript function called to initialize on that object, and it needs to be printed out in a loop. Well, I'll just pass it off to that foot block, and it all gets included, say, after my jQuery libraries or whatever. So the reason we want to do that is because, remembering that HTTP calls are expensive, if we don't necessarily have to call right away, we probably shouldn't. And a lot of the times, JavaScript just doesn't need to be loaded until the rest of the page has been rendered. So we can just shove it down in the bottom of the site because there's no reason for a JavaScript file to block the download of the rest of your HTML document or the assets that you really do need to render the page that are getting downloaded out of your style sheets, so on and so forth. Once you've done that, it's a good idea to GZip everything that your servers are sending back. It's another nice little reduction in the size of your downloads. And most devices support it, and you're getting it for free in most server configurations. I didn't actually get a chance to copy and paste a sample server config there on the right-hand side, but it is pretty easy. If you just Google mod gzip, I think it is, or mod compress for Apache, so easy to turn this stuff on. There really is no reason not to. And that's just going to be gzipping all your CSS, all your JavaScript, every response that your Rails app sends back in text HTML or JSON or YAML or plain text. Whatever you have coming through that server compresses it and lets the browser do the unzipping. So there are some caveats with that. If you are using a content distribution network, some of them don't natively support gzipping the content that they serve out. so you have to actually do your own gzipping. But we'll revisit that issue in a little bit. So if you thought those are easy, then there's some really easy ones that Yahoo recommends. Avoiding CSS expressions. To be honest, I didn't even really know what those were until I read what the Yahoo Performance Best Practices had to say about them. And apparently it's some sort of way of embedding JavaScript inside of your CSS to calculate values and colors and whatever on the fly, which apparently gets called all the time, like when you scroll your page. So just don't do it. If you are doing it, I'd be curious to hear why you're doing it and why you're not just using JavaScript. So avoiding redirects, this is something that's not necessarily endemic to Rails applications. If you're following Rails best practices, you're not bouncing users all over the place like my bank website does. Removing duplicate scripts. Again, not something that's necessarily endemic to Rails applications. If you're including a script more than once, you're doing that download more than once, and you're parsing that file more than once in most cases. So that would really only happen, though, if you're trying to do something real clever with how you're including your JavaScript files. So if you are doing something clever, you should be a little more clever and look for ways to not do duplicate scripts. Reduce DNS lookups. Again, something that's not necessarily endemic to Rails apps in and of themselves. The most DNS lookups I've seen on a typical Rails app will be 5, maybe 6 domains, and that's if you have an asset host set up to be using multiple, doing like the asset %d.whatever.com, because that'll create 4 domains for you right there, which helps with parallelizing your assets. Yahoo recommends, less than 6, I think, less than 5. So it's kind of hard to bump up against that limit unless maybe you're including things from a bunch of different buckets or, images from one domain and style sheets from another and whatever. It's pretty easy just to compress those down into a single asset host, though. So moving on from there, configuring ETags. This is a fun one because if you're not familiar with ETags, what it is when the server sends back content, it calculates kind of a checksum of that content, gives it to the browser in one of the headers. And later on, when the browser is doing a refresh or asking for that same resource again, it can say, hey, I have this checksum for this resource. Has it been updated since then? And then the server can come back with, well, no, in fact, it hasn't. And that will prevent most of the overhead of processing that request and sending the content back down. Apache gives you a lot of that for free. Any static asset that's served out of Apache is going to have an ETag on it. Rails actually gives us a lot of that for free because they calculate a checksum on all the output that when it's ready to send back that response, it calculates that checksum and throws in an ETag with it. If you are relying on that with Rails requests, though, they do have kind of a beefed up helper method in recent versions of Rails that you can use to avoid, expensive database calls or expensive view rendering, that sort of thing. Obviously, it's best to skip the Rails framework entirely if you're concerned about performance, but skipping a couple methods is nice too. So I encourage you to look up the stale method if you need that. That one's pretty neat because if you have just one resource that's the main content of this entire view, you can potentially skip rendering that entire view if the user has already seen it. There's also the, you can see there the last modified header is a useful version of that too because the server can tell the client, this is the date that I've noticed the last change to this resource. Again, the browser can come back later and say, I have a version that's this old, has it changed since then? Those are good, but now we're really getting into the meat of some of the big wins when it comes to website performance optimization. With ETags and last modifieds, the browser still has to ask the server if something's changed. Now, when you're dealing with expires headers and cache control headers, it really doesn't, because when you send that resource back to the client, you're telling it this thing will not expire, or will not change in the next day or week or year even. And then the browser will know not to even ask for that resource in that time. That's a major win because it doesn't even have to check with the server. It doesn't even bother initiating an outgoing HTTP request. It just skips the HTTP request altogether. The problem there being what happens when you do want to update, say, a style sheet. Rails has some cache busing that it gives you for free. I'm sure you've seen on the end of images, it's got the timestamp in the query params called a soft cache buster. It doesn't actually change the path of the file. Most of the time, that'll be sufficient to change the URL with the server, and so the browser and the server will both know that it needs to send some new data back to you. That doesn't work with all content distribution networks. If you're using CloudFront, it's got a section on its documentation that's pretty explicit. Pretty explicitly states it ignores anything in the query params. I think technically query params shouldn't affect that sort of expiration anyways. So what you need to do is a hard cache buster, and that is actually inserting a version in the path before the query parameters. And there's a bunch of different ways to do that, but when I was doing some research on deciding how I'd like to, based on the requirements of my site, it turned out the easiest way to do that was just to stick the revision of the deploy that you're doing right there in your asset host. And essentially forcing an expiration of all your static assets every time you do a deploy. So I can't emphasize enough how major a performance boost it is to do far future expires headers. I was one of those people who I've heard people recommend that you set them up. Never really put a whole lot of stock into it, but after I really tackled this issue of serving content from a CDN, I'm definitely sold. It makes the difference between downloading all of your style sheets and backgrounds from one page to another and literally clicking on a link and having an almost instantaneously rendered page, just kind of ready and waiting. Even on a cold cache, it's really impressive. So even if you're not using a content distribution network, I would say look into mod expires for Apache. Make sure all your JavaScripts and CSS files are set to expire, a year in advance, and I think you will be pleased with the results. Finally, getting to the real meat here, using a CDN. I was pretty excited when Amazon announced CloudFront a few months ago. If you're not familiar with it, what it is basically is a CDN that runs on top of S3. You tell it an S3 bucket. It gives you a domain name that you can use, or you can even tell it, here are some domain names that I'd like you to recognize, and just CNAME them to the one that it gives you. It's got servers all over the world, a handful in the States, a handful in Europe, a couple in Hong Kong, and I'm not really sure where else. Which is a big win for users because you're going to be reducing the physical distance of the user to the server potentially. And that's great for the latency of sending requests and also getting the responses back. Not necessarily important for all sites. I am working on a couple that definitely have a global audience. So, and of course, every year the internet's getting more and more global. So that's always a nice thing to consider for your users' sake, because it may not bother us when we're downloading data from a server in San Jose or something, but if you're in Hong Kong or London or Australia, that's gonna definitely be noticeable. So I was all set to have the CDN be a big, complicated issue, but with CloudFront, it really is just as hard as uploading to S3. And this is a really simple script to upload all your files to S3. I ripped most of this off of a blog post somewhere and just kind of rewrote it to my needs, trying to trim it down a bit. I'll just walk you through some of the basics. I'm grabbing the AWS S3 gem to do my uploads to S3. Because I like progress bars, I got the progress bar in there as well. And I'm actually loading my environment to RB because that's where I have a small snippet of code to just read the revision out of the revision file. As well as it gives me the Rails root and stuff. Next, we just set up the S3 connection. I'm grabbing my keys out of an Amazon.s3.yaml file. grabbing the bucket out of there as well. Here we're just looking for all of the interesting files. I'm explicitly specifying extensions in this script. I don't know that that's really necessary. And all those asterisks are in there to follow symlinks down one level, because in the site that I wrote this for, I'm also uploading all of the, there's some user uploadable assets, and I want all of those up on the CDN as well, because Rails is generating links and is going to expect them to be there anyway. So, and then we're also just kind of setting up a basic progress bar. So from there we start iterating over all the files, skipping the directories, because we don't really care about uploading directories. And here's kind of the meat of the strategy here. For each of these files, we're taking the path and we're generating a key that includes the revision of the deploy. And so we're just substituting that entire path all the way up through the public directory and replacing that with the revision. And that means I'll get URLs later on like assets.example.com / some long git revision string / JavaScript application.js, so on and so forth. And then we're just, from there, once we've got that key figured out, we're just kind of shoving it up into S3. You can notice there I've got the access turned on to public, but more importantly, setting it to expire a year from now. And that's really the essence of the script. It really couldn't get simpler than that. That's all you need to serve your files out of CloudFront on a Rails app, plus a few other configuration bits. I was really surprised when I set out to see how hard or difficult it would be, and it really was not that difficult. So put all that together and you've got an A in YSlow. It's not a perfect A. You can see I've got a D on gzipping, which brings me back to one of my points. Because CloudFront doesn't support gzipping the content that it serves, you actually, if you want gzipping in the CDN, you need to upload two versions, a gzip version and a not gzipped version, and then hack Rails' asset helper to detect whether the device you're talking to supports gzip or not. I mean, you could assume that they all do, but they don't all support gzip. And notably, some kind of proxies that your user might be behind may not support gzip. So I elected not to do that. The big win here is the browser cache. So that initial download, I mean, mostly of minified JavaScript and CSS files, seemed to me like enough of a win that I wasn't going to stress too much on that. But other than that, for a fairly simple site, it made things pretty snappy. There are a couple other caveats with my particular strategy for expiring your assets, and that is because I'm expiring it on every deploy, it means I'm also uploading all of my public assets on every deploy, and that may or may not be a big deal for you. If you've got hundreds of megabytes worth of public assets, you'd probably want to go for something a little more clever, like including a checksum of the file in the file name, or just the timestamp of the last modified date of the file in the file string. That requires a little more hacking of the Rails asset tag helpers in order to generate the paths that you're going to expect from that. So I didn't quite opt to go that route, but if you want to tackle this problem and you need to not be uploading every asset every deploy, then I'd be happy to bounce some ideas around with you if you want to hack on that. So all of this is forthcoming in an article. I'm going to put it on my website, which I keep promising to myself that I'm going to start a blog on. So now that this is in the podcast, I will be shaming myself into starting that blog. So I've got this all written out. I've got tons of, cut and pastable snippets for you if you are curious in setting all this stuff up. Really, I mean, this is all this kind of stuff. If you haven't already run through this, I'm sure plenty of you already have on some sites. It's less than an hour of work, and it makes all the difference between, I mean, it'll feel like you're serving static HTML in a lot of cases, and that's always really nice. So yeah, that's pretty much everything. 27 minutes, pretty good. So anyone have any questions about any of that, or What do you think? Rob?
One comment. You really want to verify that you're not serving your assets through Rails.
Mm-hmm.
A lot of times I'll go in to work on someone else's server and their Apache or Nginx configuration isn't quite right, and they're serving all of their static content through the whole Rails stack.
Mm-hmm.
And that alone can be just a huge saving.
That's a good one. That really fits with the handbrake metaphor. So Rob points out that before you deploy that site, definitely check to make sure that it's configured so that the static assets aren't going through Rails itself, right? So that it's being served out from like Apache instead of Rails. Yeah, that would definitely kill your performance. It's a good one. Questions, comments, anyone? Has anyone else set up a Rails site with like a CDN, S3, CloudFront, Akamai? Yeah? Which one?
A site I worked on about, we just use S3.
S3.
Just for like image uploads.
Mm-hmm.
Check out CloudFront for that.
The nice thing about S3 is if you have uploaded anything to S3, is it's literally, a ridiculously simple configuration to get it running on CloudFront. And then you've got the benefit of servers all around the world that it's being served out from. So that's pretty sweet. See, the thing is, the delay on CloudFront varies depending on what server you're getting and where you are in relation to it. So I've seen in comment threads that talk about CloudFront, people complaining about latency up to like 200 milliseconds just to talk to the server, and other people talking about 20 milliseconds. So
for propagation of the data.
Propagation of the data happens like this. When you send that request, okay, so first of all, you've got your domain name. It's CNAMEd to its special domain name, which then resolves to a handful of different IPs. I'm not a DNS expert, so I'm not sure how exactly it decides which IP you should be talking to. But once you have that IP, you ask the server for the object. That first request is a little slower because it needs to go and talk to your S3 repository, and then it pulls it out to that edge server that's serving the content and then serves it back. And then from there, any other request to that same object is going to get served out of that edge server's cache. So for all the new stuff that you put up, there is like a cache warm-up on all those edge locations, and you actually do pay for those requests too in S3, incidentally. And yeah, that's kind of how that works. I think they have some kind of expiration policy, like if you've got something that's just not being used after a certain amount of time, it will get kicked out, and it'll have to be re-requested. And I don't know exactly how long that takes to get it from your S3 buckets into the CloudFront servers, but it seems fairly negligible to me. Like when I do a deploy and everything gets busted and then I go and refresh, it's all pretty much insane. It's no slower than when I was serving it all straight from the server that Rails was on. So.
Well, if it's completely blind to you because you're seeing.
Well, yes, and I'm all excited about how cool this is. So.
Well, what I'm saying is you're seeing the S3 servers in Northern California.
Yeah.
Which is where you're uploading to.
Yeah.
You're never seeing the delay to copy it all the way to Singapore.
Yeah, totally.
So.
That's true. If I was tunneling myself to Hong Kong and doing a request, I might notice the difference a little bit more. But
that's when proxy server is fun to play around with, so you can see what does it really look like from England. What does it really look like if you pretend to be from Hong Kong?
Should try that. Anyone else, or should we move on to the raffle? Raffle it is. All right, thanks, guys.
That concludes this episode of the SD.RB podcast. See you next time.